Hi everyone. We are here to talk about the new attack affecting the Windows Server update architectures, which is represented by WSUS. But first, let me introduce myself. I'm Yves from the French National Agency for IT Security. I'm an IT auditor for more than 10 years, and I'm specialized in database security, SCADA, and many other domains. And here is Romain.
Hi everyone. I'm a former auditor who works with Yves. I'm now working at Alcid, which is a French company doing Active Directory security. Well, I'm doing a lot of R&D on various Windows products now, so our presentation here with Yves is just opportunity.
So, to show you the usefulness of the WSUS attack we will present later, we're going to start by presenting you a classical attack scenario we encountered many times during penetration testing, and where the aim of the attack was to compromise the Active Directory domain. So when performing a pen test, we look to gain a foothold into the targeted network. This may occur through social engineering attacks, such as phishing campaigns, as shown here. But that can actually be by many other means, like compromising misconfigured servers, such as Oracle, Tomcat, GBoss, which often have default configuration, which often have default credentials and run as system on Windows environment. Second step is usually performing a network scan to discover the network. With it, we discovered that some workstations have vulnerabilities, some passwords are reused, so we can pivot on various machines. One of these machines has an administrative account for some servers connected on it. And so we can obtain this password hash in the memory and use it to compromise a bunch of servers with the password hash technique. By performing lateral movement on these servers, we finally find an Active Directory administrative account that allows us to get domain secrets. With that, we can compromise all the networks, which led us to obtain all data from the new secret projects, details from the developers' computers to the CEO strategic email. Okay. We compromise all the networks, and it was too easy. And in this situation, we don't have anything more to say about it. But, oddly, we could be in front of good administrators that have applied security best practices based on ISAE model and Active Directory administrative tier model defined by Microsoft. Let's see how we can compromise an ISAE managed forest. In classical administration, probably the one used in the previous example, there are often a lot of administrative accounts. All these accounts administer all types of resources. That is conducted to put their credential on all machines. This situation leads an attacker to easily obtain domain administrator level by compromising a little number of servers. By obtaining the password hash in the memory of the control servers, it is possible to perform pass the hash or pass the ticket attacks on every equipment. Thus, the worst situation is when an administrative account is connected on a workstation that could be under an attacker control. To avoid that, a solution is to separate privileges in at least 3 different security zones named tier. Tier 0 contains accounts, groups, and assets that have direct or indirect administrative control of the Active Directory forest, domain controllers, or all the assets in it, including the identity management. Tier 1 includes servers and applications. This is typically where we find the WSUS servers currently. And finally, Tier 2 contains workstations and devices. The last zone is the less critical one in terms of privileges, even if it contains business data. These data are spread across multiple workstations and need a thorough investigation to find relevant ones with the right access. Each zone needs to be isolated, which means that an administrator in a specific chair is not able to connect to another chair for administrative purpose. With this configuration, it is not possible for an attacker to elevate his privileges, as no privileged account from the top level is available in the system memory of the current level. Indeed, the administration segmentation forbids network connection for administrative accounts from top level to lower level. In this layout, a tier 0 administrator is able to administer domain controller, for instance. But connection and server in tier 1 is restricted. Tier 1 administrator has no privileges on tier 0. They can't control domain controllers, but they can control all servers. They use the tier 0 resources as any regular user does, mainly for authentication purpose. This separation is included in a Microsoft model named ESA, Enhanced Security Administrative Environment. The primary goal of the ESA model is the protection of the administration credential. This model is based on one on-more production forests and one administrative forest. The administrative forest is configured as a single domain in a single forest. It is essential to have a small number of users in this forest and even a small number of administrators, with no users also being also used for administrative purpose. These regular users are intended to administrate the other forest, but have no right in the administrative forest. They only have connection right on tier 0, resources, and production forest. Workstations used by these users need to be particularly hardened. To join production forests, a one-way trust relationship using selective authentication needs to be configured. The production forest need to trust the ESA forests and not the other way around. In a network, why do we use an ESA? Without it, after compromising a server, compromising the rest is easy. With it, as we have no active directory domain administrator connected to a compromised server, attacker will not compromise the domain controller, thus some assets won't be compromised. Okay, to summarize, the advantages of an ESA are that it helps protecting tier 0 resources from a risk of compromise and therefore prevent an overall compromise. And it can use the same active directory account to administrate multiple forests. In fact, what the ESA model is guaranteeing to you that is if a production forest is compromised for whatever reason, the administrative account won't be reusable on the other production forest. But if you only have one forest, this guarantee is not very useful. So you could stick with having well-configured tier 0 administrators in your production forest. That will save you a lot of money. However, ESA model doesn't protect enterprise assets, but that's a mandatory step to get to that. Without this first step, trying to protect business assets is just a wild goose chase. If we go back to our pen test, it's exactly the network configuration we are confronted to. With this scenario, top-level tier is not reachable, which sucks, and as pen tester, we have to find a way to get there. So, is it possible to compromise an ESA managed forest? Apparently, you can't. But by deeply analyzing these servers, we've realized that a WSUS server is present in tier 1, where application servers are located. We thought that maybe we could use it to deploy specific updates to control all the clients. And among these clients, perhaps there are some tier 0 servers. So the question becomes, is it possible to compromise an ESA managed forest using a WSUS server?
And to answer this question, we need to understand how the WSUS architecture is working. So here you have a WSUS server into a classical enterprise network. The WSUS server is synchronizing its update with Microsoft update servers. There are two parts in the updates. The first part is the metadata, which are synchronized over an HTTPS secret channel. The other part is the binaries, which are synchronized on an HTTP channel, which might be a problem, but actually isn't, because of the signature of the binaries. Anything not signed by Microsoft or a trusted third party would be rejected, so no one can tamper with the binaries. On the other side, inside the enterprise network, the clients of the WSUS server will regularly fetch new updates. And these clients could be anything else from workstations to servers, like filers or domain controllers. Domain controllers will be our focus here. Inside the enterprise network, by default, everything is synchronized using HTTP, so no TLS is enabled. The updates are applied using full system privileges, as critical components need to be replaceable, so you need full privileges on the WSUS clients. And if we dive into the WSUS server in itself, we can find three main components. The first one is the Windows service, which is in charge of synchronizing with the Microsoft Update servers. On the other side, you have the web server, which is an IIS web server with multiple web services, which is in charge of dealing with the clients, basically. And in the middle, you have the database, which is in charge of storing metadata concerning the updates. To understand how these three components interact with each other, I'll accompany you for updates for an update journey. Sorry. So here you have the initial state where everything are on the Microsoft Update servers, metadata and binaries. So the Windows service here is synchronizing the metadata. That's the first step. Again, over an HTTPS channel. In the metadata, you can find anything related to the updates. So it's basically the updates description. You have the binaries, everything related to binaries, so their signs, the download URL, eventually maybe the command line arguments, and everything else. But the Windows service is actually giving all these metadata directly to the database. And it's the database that parses the XML files and incorporates the information inside the relational table of the database. Afterward, there's a step of verification that the administrators need to do. It can be automatically approved using automatic approval rules that we will talk about later. And when the updates are approved, by default, the binaries are downloaded. And the first thing the Windows service does after downloading the binary on an HTTP channel is to check the signature. Again, if it's not a Microsoft signed binary, then it's rejected. Otherwise, it's copied to the web service, on the web server, for the clients to be able to download the binaries. It's only from this point on, not before, that the WSUS clients can see the new updates that are approved. So let's see how this goes. The WSUS clients will fetch regularly for new updates, and then the web service will answer them by taking all the information from the database. Then each WSUS client will be able to parse some XML files and see if the update applies on this particular client. The conditions here can be anything from what if this registry value this registry key, has this value, or if this program is installed and has this version, then you apply the update. If not, no. Well, when a client decides that the metadata, the update needs to be applied, it will download the associated binary with the updates. Again, the first thing WSUS client here does just after downloading the binary is to check the signature. So you have two signature check on the binary. I didn't mention it, but binaries can be anything from a PSF, a cabinet file, or more interesting for us, an executable file. The executable file has a particular handler on the WSUS clients. It's their command line arguments can be passed can be given into the metadata. So the executable can have arguments. Then the binaries are applied, well, executed, really, again with system privileges on the WSUS clients. Now there are 3 components here, but 2 are really hatches, the Windows service and the web service. One is interesting. One interesting is the database. So let's see how do you use it. All information about how to connect to the database can be found in this registry key. So you have everything: the SQL server name, the SQL username, password if you need it, the database name, and so on. Just a quick note about the SQL server name here. The Microsoft SharpSharpWid isn't a real server name. It's actually an alias for a Windows internal database, which is a light SQL server that you can install directly with WSUS. So it's actually not a server name. Again, it's a name of a pipe that you can reach the SQL server. Once you are connected, you have access to the full WSUS configuration. You have access to full updates metadata, the approvement states of the updates, the superseding between updates, and so on and so on. Everything is stored really into this database. It's quite a big one, actually. Now that you all know how WSUS server works, we're going to talk about the state of the art of the attacks on WSUS. And it's going to be quick, because there's only one attack that has been presented on WSUS. It's WSUSpect, which has been presented here 2 years ago. And I just walk you through the description of the attack briefly. So here you have an enterprise network, classical. The idea of WSUSpect is to gain a man-in-the-middle position between the WSUS clients and the WSUS server, and wait for the clients to seek for new updates. Then it intercepts the response of the WSUS server, and as the metadata unsigned, it can inject a new update, a new fake update, into this part of the response, and give it to the client. The client then sees this fake update. It will be forged so that the updates will be installable by any client. So the client will try to download a binary. The binary here has to be signed. WSUSpect found 2 binaries, which are PSExec and BGInfo. These 2 binaries are signed by Microsoft and take arguments in their command line to execute arbitrary commands. So that's how you have command line arguments into the metadata, a signed binary, so you can compromise the client. Again, the binary is applied with full system privileges, so you can do anything you want on the client. This really is an awesome attack. It's really interesting to use this, but there's some limitations. The first one is that you have to get a man-in-the-middle position. So if there are network limitations like private VLAN or anything else that prevents you to gain this man-in-the-middle position, then you're basically screwed. The second one is that when you have this man-in-the-middle position, you need to get a useful one. Microsoft is really pushing forward to enable TLS inside your enterprise network between the WSUS clients and the WSUS server. So maybe when, even if you have a man-in-the-middle position, you won't be able to intercept and inject the stream of the metadata. So in our case, that doesn't give us access to the easily managed domain controllers. So we need to find something else. So just to sum up where we are now, we know that injecting metadata between a WSUS server and its clients is possible. We know that metadata are stored into a database, and we know how to interact with this database. What we want is to inject a new update as part of the metadata, but without a network attack. So I think you see this coming, but we're going to try to inject a new update directly into the database. Well, first we need to try to insert some data into this database. So we looked for update information inside the tables. We found some. There's a table named updates, so that's great for us. We tried to insert data into this update table, and actually, well, it wasn't as successful. There was a trigger saying, nope, you can't directly insert metadata into this table. You have to insert it into another table before. Okay, we try to respect this trigger. Then, nope, that's not good either. This time it's not a trigger, it's a foreign key. So, yeah, of course there is foreign key into the relational database. That's okay, but so we treated the relationship between the tables, mapped this, all the foreign keys used. That was really painful, actually, but we managed to do this, and we tried to insert data into the table, and well, to respect the triggers and the foreign key constraints. And again, there was another trigger saying, nope, you can't do that. So we're talking about around 10 or 15 tables that we need to insert before inserting into our own table where we want to. So at this time, we were just thinking, that's way too complicated. Let's try something else. So the second try is, instead of the triggers being the problem, we tried to make it the solution by making them trace insertion during WSUS synchronizing with the Microsoft Update service. Remember, there is under tables, and when you synchronize the updates, it's a really huge information. And actually, this wasn't really helpful because there were too many information here. The second thing is we tried is to use the audit logs of the SQL server to trace insert. But this time there was too many, well, not too many. The logs were binaries, so it's not really helpful here. Again, it's really too complicated. It's at this time that a colleague of ours just said, why don't you use the SQL profiler? And indeed, the SQL profiler here monitors everything done on every query done on the database. So we use it while the WSUS server is synchronizing with Microsoft Updates, and we managed to have 3 repeating queries that are done on, no, not 3, 5, sorry, that are done on the database. And actually, all the queries aren't done on the table directly, but are done through the stored procedures. Everything the Windows service is doing while querying the database goes through stored procedures. And it's the stored procedures that take care of all the foreign keys and triggers constraints. So here you have the 5 stored procedures. Actually, only 4 are useful to us. The first one is to import an update for the server-side part of the update. So that's for basically the MMC console. The second one is for the client side. So it's called a bunch of times for all the languages that a client can have. The third one is to link updates metadata to the binaries, so that you have the link when the update is approved, the binary will get downloaded. And the fourth is to run the automatic approval rules that you have just after inserting the new updates. So here we have the for call. So we try to get this for call for a valid update and try to modify these valid updates to have a fake one. The first thing we encountered here at this step is that Microsoft is actually using image-typed columns to store binaries. So when you grep into your log to modify the information, you can't grep into these columns. So that's something that you have to think of. When we managed to get a proof of concept, we managed to make it work on Windows 7 and Windows 10 at the time, the latest version, the 1607. Well, actually, the proof of concept didn't work at all on all the versions in between. But finally, we managed to make it work on all versions.
So, after understanding the WSUS internals, we are able to develop a tool to automate the attack. This tool is named WSUSpendu and is freely available on GitHub. WSUSpendu performs a direct injection in the database in order to be persistent. To perform attack with the tool, we need signed binary and specifically crafted metadata. We use signed binaries, like with the WSUSpect, to respect the signature verification procedure, and so it is possible to use various tools that are signed by Microsoft, such as PSExec or BGInfo in the sysinternal suite, but also MS-Build, InstallUtil, and others. By following some projects that bypass app locker policies, you can find other binaries. We use the WSUS database in order to inject well-crafted metadata by using the different store procedures to respect data consent and data consistency. So we even injected metadata in the database in order to deliver information update for the clients. We have dropped the binary into the IIS directory where the client could download it. And when the clients want to check if a new updates are available, the database provides information about the malicious updates. And the clients download it, thinking it's a legitimate one. Once these updates have been downloaded, the client checks the signature, and since it's OK, clients install it with system privileges, as previously mentioned. We have a video to demonstrate what could be done once we have compromised and WSUS servers. So we are on a WSUS client. We don't have absolutely no privileges on this client. We have no account, and the aim of the attack is to add a new user on this client. If we check the user list, we can see that only the administrator account is present. Okay, we go to the WSUS servers, and as we have compromised it, we can copy the binary into these servers. We can launch WSUSpendu to inject the malicious update. So we have to precise some arguments. The first one is to precise that we want to perform an injection, and we want to inject a payload. The payload is PSExec in this case. And for PSExec, we want to precise some arguments. First one is accept EULA, because if we don't precise it, a pop-up will alert the user on the targeted computer that something wrong is happening, and obviously we don't want that to happen. After that, we want to launch a command. The command is to add a user in the targeted computer, and as the update will be launched with the system privileges, we take advantage of that to add the user in the administrator local group. The last thing we can precise is the computer name where the update will be deployed. By doing this, the updates will be automatically approved for this computer. Okay, we can verify in the MMC console if everything is okay, and after refreshing, we can see our updates. We can see that the update is approved for one computer among the 4 declared in the WSUS servers. Okay, we can go back to the WSUS client, and we have to wait that the client check if a new update is available. So we can force it with, by clicking on checking for updates. And if an update is present, the system will download it and accept it with the system privileges as it. Now we can check the user list, and we can see that the new user is present. If we check in the user groups, you can see that this user is a member of the administrator local group. So, mission succeeded. Okay, if we go back to the pen test with the production forest, we can verify that the WSUS servers has delivered these updates to the different servers. And among the affected servers, there are some domain controllers. So I guess the answer is that we can actually compromise the production forest. Sometimes we can have a more dangerous configuration that could conduct to the compromise of the ISAE forest itself. Indeed, we could be in a situation where the WSUS server in the production forest distributes its updates to the ISAE forest itself. This configuration is not what Microsoft recommends, but can be validated by them due to the Microsoft client's desires. This situation is technically possible due to the WSUS server chaining. Sometimes companies have a more complicated network. It's multiple domains, lot of network, lot of machines, subnetworks, and so on. In this case, having more than one WSUS server could be better. As an example, WSUS server could be specific by country for a worldwide company. If we go back to the initial architecture, the WSUS server delivers now its update to another WSUS servers that will deliver the same updates to his own clients. In this case, we can define 2 kinds of servers, an upstream server and a downstream server. In another term, a downstream server is a WSUS server that receives updates from the upstream servers, and an upstream server is a WSUS server that delivers updates to a downstream server. By extension, the uppermost server in this chain is the Microsoft update server. Okay, we have a path to control the Microsoft most secure environment, but we need to go deeper. If we go back to the first pen test, we have compromised the network very quickly. But during the pen test, we read some documentation, we found configuration files, and with this different information, we read that there are another network using another domain in this organization. But this network can't be reached because it's not connected to the current network nor to the internet. Isolated networks are often implemented in case of industrial network or classified network. This kind of network is usually disconnected because of its sensitivity. If it's not reachable, there are no security issues. In the first pass, we compromise only a connected network. How about disconnected ones? As we know, these networks have no open-doors except USB devices, but this is an uncertain path. But if it's a good security practice to isolate a network, we need to keep in mind that servers within this network need to be kept up to date. This situation is planned in WSUS process. Indeed, it's possible to extract metadata and updates from a WSUS servers connected on the internet and to copy this information to an external device and to import them in the WSUS servers located in the disconnected network. To do that, Microsoft provides the WSUS util tools to perform metadata export and import. The updates binary needs to be manually copied. This situation is relatively slow, as mentioned by Microsoft. A most common solution is based on the usage of WSUS servers installed in a virtual machine. The administrator has just to clone the virtual machine and transfer this clone into the disconnected network. With the Microsoft solution, once updates are imported, another step is required. Updates need to be approved. But the WSUS servers on a disconnected network is often configured with auto-approval rules. These rules usually depend on the classification of the updates. So if you use a critical or security updates one, we have a great chance to be automatically approved. If not, we can choose a name for the Microsoft bulletin in order to incite the administrator to manually approve the update. I think if you choose the Microsoft bulletin MS1710, you maximize your chances. Okay, let's see how we can do it. We are on the aftermath of a global attack like WannaCry. Administrators have to patch their system very quickly against the vulnerabilities described by the Microsoft Bulletin MS1710. As we are an attacker, we want to gain advantage of this to compromise the connected network, but also disconnected ones. So we are an attacker, and we have compromised WSUS servers in the connected network, and we can copy the last time the WSUSpendu tool to perform injection, and this time we don't want to add a user because it's not really relevant on a disconnected network. So we can launch PowerShell where the argument is an uncoded payload. We'll see later what is this payload. This time we can't specify the targeted computer because no computer in the disconnected network is known on this WSUS server connected on the internet. Okay, we have performed the injection. We can verify again in the MMC console, and we can see our update. We can see that this update is not approved, and normally an update is downloaded in the WSUS servers only if the update is approved. But in the case of WSUS servers, in the case of WSUS export servers, administrator has to change the option. So if he verifies the option, we can see that the administrator has unchecked the download update files to this server only when updates are approved, and it's not the default configuration. So everything is okay. We have now to wait that the legitimate administrators perform his work to export the data and import it to the disconnected network. To do that, administrator has to copy the WSUS content of the IIS directory to an external device and to launch the WSUS util tools to export metadata from the database to the external device. After that, administrator just have to eject the device and to transfer it to the disconnected network. Okay, we can see that the update is imported after copy the WSUS content directory and launch the WSUS util tool to import metadata. We can see the update, and we can see that some information are set, like the classification of the update, and some information like the Microsoft Bulletin, MS1710, and the description. All this information are set in the metadata, so it's controlled by WSUSpendu. Now, the behavior of the update depends on the configuration of the WSUS servers. If we check in the option, we can see that a default automatic approval rule is set. And this rule says that if the update has the security update classification, the update will be approved. So everything is okay, and we can go on a victim and a client in the disconnected network, and we have to wait that this victim check if a new update is available. So we force it by clicking on checking for updates, and we see that the update is arrived, downloaded, installed with system privileges, and this time an error is appearing because the update is not a real update, and we have no way to verify that the update is really installed. But it's not a problem, and everything is okay. The attack is okay. Okay, remember that the administrators has to patch their system very quickly to avoid a major compromising. But this time, the effect is a little bit different than expected. So in spite of our disconnected, not reachable network, we have a path to transfer malicious updates to the targeted network and to compromise it.
Well, that's all scary, really. But how do you protect yourself against that? Well, the first thing is to listen to Microsoft and apply the first recommendation that they are saying. The first thing is to activate TLS, and Microsoft is really pushing for it because even before you install the WSUS role on your server, Microsoft is already saying to you that you need to install, to enable TLS. That will protect you against WSUSpec, that won't protect you against WSUSpendu. What you need to understand for WSUSpendu is that you have a control relationship from the WSUS server to all of its clients. So in this case, when you have a WSUS server that gives its updates to the domain controllers, you have to put the WSUS server into the same tier as the domain controller are. Now, if you want to be very precise, the WSUS server needs to take its updates from Microsoft Update, not from another WSUS server here. That way, the path will be safe to apply the updates on the domain controllers. If you really want to have WSUS updates on the tier 1, you can, but you need to be aware of the direction the updates are given. It's the WSUS server inside the tier 0 that gives its updates to the WSUS server inside tier 1, not the other way around. For the disconnected networks part, the problem here is that we compromised the WSUS server on the internet-connected network. The problem with internet-connected network is that they have legacy systems that they are very hard to protect. So the idea is to use a dedicated network with enhanced protection with no legacy problems that you can have on a regular network, dedicated to WSUS server, which can export its updates to an import WSUS server on the disconnected networks. Another step to enhance this protection is for Microsoft to sign the metadata, and that's exactly what they are doing currently. We can find this into the Windows 10 17.03, the Creators Update version. It's the beginning of the metadata signing, and it's really interesting for you to be there. Of course, the easiest way to stop all these attacks is to stop updating, but I don't think it's a really good solution, so please don't do that. I hope you understood that there's a control relationship from a WSUS server to WSUS clients. All you need to do is to be aware of that and take it into account into your architecture. Thank you all for your attention. If you have any question, I think we have enough time. Any question now? Yeah.
Is there an upward limit for the arguments that you can plug into the payload arguments as far as the size?
This isn't enforced by WSUS, but it's enforced by the command lines argument. So I don't remember the limits, but yeah, there is one. Indeed.
Can you accomplish the same thing if you're using SCCM to deliver the updates as opposed to just the WSUS server on its own?
That's a really good question, actually. I need to repeat the question just for everyone to understand. So the idea is to use the SCCM database in the same way as we are using the WSUS database to deliver malicious update. The thing is, we didn't check it. So I can't say you that it's possible, but the way things are done on the SCCM is most probably the same thing that are done on the WSUS side. Was it
more of an issue that you found with just the WSUS server with the SQLite that came with it? So the SQL server that was part of the WSUS server?
I'm sorry, I didn't understand. Can you move forward just?
Sorry.
Thanks.
Was the problem that you saw mostly the SQLite server that was part of the WSUS server? Is that where you saw the issue, that implementation? Is SCCM has its own database, but uses the WSUS component in every operating system in order to transfer this information?
I don't know how SCCM works exactly.
Okay, thanks.
If there's no other question, thank you all for your time.